Hello again, and welcome to the AI for Clinician Champions Program. It's overall part of our AI in healthcare education programming. And we've got Alex here with us. Alex is working on our assignment 2, and he's one of the TAs in the program. Alex, welcome. Tell us again who you are and how you came to be in this program.
Sure. Hi, everyone. My name is Alex. I am currently working as a data engineer at a health AI startup, but my background was actually in psychology and human biology in my undergraduate degree at the University of Toronto. And then I pursued my master's at the University of Waterloo, and I studied computer science, and specifically AI and applied computing.
Fantastic. All right. All this to say, Alex is very qualified to be telling us everything we need to know about regression today. My name is Shingai. I'm the course director for this program, and I'm the director of professional development at the Vector Institute. And we are bringing you these case studies and assignments that we've made with love to teach you and to get you to think about some of the important aspects of artificial intelligence and data, really, the use of data in decision making. All right, so Alex, the floor is yours. Go ahead, tell us about this assignment.
Sure. So the assignment, we're really digging into the use of regression models. And before we get there, we're just gonna cover a couple of definitions. And broadly speaking, we're dealing with supervised learning. What that means is when we have a data set, we have all the data labeled, right? So we have various examples and samples and data points, and then they're going to have the correct outputs that we wish to predict. And in the case of regression, that output itself is continuous, right? So it might be some sort of a numeric value. And in the case of classification, it's going to be some sort of a discrete value. So things like yes, no, 0, 1, and what have you. Okay, so in terms of the assignment itself, it's separated into 5 different portions. So we have the data set, of course, we import that data set, and we're sort of going to explore that data set, and that's called the exploratory data analysis, or EDA. And we're going to pre-process that data. So we're sort of massaging the data so that it could fit into our model properly, so that once you do the modeling and we make predictions from there, we can evaluate how well our model performed. So the data set, it's a publicly available data set, and there are various demographic and health informations. And as you can see, there are variables like age, sex, BMI, number of children that the patient has, whether the patient smokes or not, where they live in the United States, and the medical cost that the insurance company has to pay. So for the exploratory data analysis, given the previous variables, things like age, BMI, children, sex, smoker, and region, our main interest was sort of to predict medical cost, right? So hence the y-axis. And here I'm just showing the relationships between these variables. So in terms of age, there seems to be an upward trend, as well as BMI category. Those that are obese tend to incur more medical charges. There seems to be sex differences in the medical charges, and not surprisingly, one's smoking status tends to have an impact on the smoking medical charges as well, and some regional differences. Okay. And these are just additional aggregate plots to capture a little bit more nuance in the data set. So digging a little bit deeper into the smoking status, smoker, non-smoker, we can sort of separate them into look at the sex differences as well, where male smokers tend to incur more medical charges than women or female smokers. And in the case of looking at the BMI categories, those that are obese are going to have higher medical charges than those that are not obese. And these are basically clusters that's observed. One on the left is through the use of k-means clustering algorithm. And there are 3 optimal clusters. And on the right is sort of manually putting the colors to separate the clusters. So in this case is the BMI and whether one smokes or not. So there's a clear separation between the blue clusters and the green clusters. Okay. So once we've sort of done the exploratory data analysis, we can sort of pre-process the data itself so that we can move on to the modeling. And what that entails is we're encoding the non-numeric features into numeric values. So things like sex, female and male, we're going to turn them into numeric values 0 and 1. Smoker is going to be the same, no, yes, turn into 0, 1. And the regions are going to be encoded to 0, 1, 2, 3. And now our model will be able to take these features and learn these features and learn from our data set, and then hopefully make the correct predictions. Okay. So first, as I mentioned, we're using a linear regression. And again, just to recap, the goal is to predict continuous valued output. And here is just a generic picture of a linear regression and what might be happening, which is we have some data points and we're hopefully going to learn a line of best fit that's going to be able to explain this data as best as it can. And so again, in our case, we're going to try to predict medical costs given all our features. And hopefully by this time you've run sort of the Google Colab notebook. If not, that's okay, but these are just the evaluation metrics that we get. So MSE, mean squared error, we get a value of 0.35. This is a pretty good value, and MSE is going to basically range from 0 to infinity. And we want to minimize this as much as possible, because this value is measuring the actual value versus the predicted value. So we want to get to, our prediction should ideally be equal or as close to the actual values. And in the case of R squared, the coefficient of determination is sort of giving the, how well does the data fit into our model. So if you remember the linear line that we saw in the previous, right here, it's basically giving a numeric value of that. And that value ranges from 0 to 1. So we can conclude that, okay, our model is fitting quite well at 83%. Okay, so moving on to the classification problem, we're gonna utilize logistic regression, where the goal is to predict discrete valued output. So in our case, does our patient smoke or no, right? And similarly, before we had a sort of a linear line, and now we impose this, what we call a sigmoid function, where you sort of get this characteristic S curve, and basically all the values that fall perhaps in this region might be smokers, and all the values that fall in this region might be non-smokers. And this is, of course, for classification, we're using different metric values. So here's a confusion matrix. that's basically showing the true positives, false positives, and false negatives and true negatives. And on the right, we have the different metrics, things like precision, recall, and F1 score. And again, all of these values, we want to get to as close to 1 as possible, right? 100%. So in the case of non-smoker, precision is 100%, recall 95%, and F1 score is trying to balance those two, so it's at 98%. And overall, another way of saying it is just our model is performing very well. Okay.
All right, well, yeah, that takes us into the actual assignment itself. So look, some general discussion points. This data obviously is based in the United States, where healthcare insurance is, a really big topic. And in Canada, sometimes it's not visible. As patients, you go in and you provide your health card, and you don't have to necessarily at that point of contact necessarily deal with the costs. But since we've done this analysis, if we had to abstract, if we had to use this type of analysis to try and make some decisions and try and, is this analysis reliable? We've put together some notes and comments and a bit of a case study to help you think through, you've done a data analysis. How good is it? And can you trust it? And what happens with it going forward? So here are some questions. And Alex, I'd be interested to get your take on this. It's a discussion. So obviously, if you have a different opinion, we'd love to hear about it. That's what the assignments are for. They're to get you to think and to think critically. So we're going to hear some notes and comments from Alex. So the first thing is just setting the scene. Suppose you're dealing with the hospital auditor whose main goal is to reduce hospital costs, right? So that's the objective. Someone is here primarily to reduce costs. Based on this data analysis we've just done, the auditor suggests that your hospital should have a capacity limit on patients with high BMI, as they are likely to incur more medical costs. Now, first things first, Alex, is this something that's in the data, or is this auditor making it up?
I think it's fair to say that this is in the data. Yeah. So we saw that the higher the BMI, the higher the medical costs that one was occurring.
All right, so the data analysis does show this. So the auditor is speaking from, we're going to call it a factual basis, fact being based on the data analysis that we've conducted on this data set. All right, the fairness of this. Is this a good way to go to try and reduce costs? I mean, if you say limit capacity on patients with high BMI, what does that even look like? Are we going to turn patients away? What are your comments on the fairness of trying to do something like that based on this analysis?
Mm-hmm. So I'll stay pretty neutral so that I can give everyone to sort of discuss their opinions, and I don't want to sway anyone's sort of response. But given the data set, given the analysis, it's fair to say that one can come with this conclusion, right? And whether this is fair or not, right? That's a question of, okay, well, if we're trying to maximize, your hospital's profit, right? It makes sense. It makes sense to sort of, okay, maybe we need to sort of quote unquote kick some of the patients out after X amount of days, right?
Okay, all right. I see what you're doing.
I'm not saying that that's a reasonable thing to do, or it could be depending on your role and what your objectives are, right? But that is a solution, right?
Right.
Based
so this is
on the data itself.
Got it. All right. So this really draws out something interesting, which is that push and pull between care and the reality of running a facility, be it a hospital or a school or any kind of facility where you also have to manage costs. So when you have an auditor or a data scientist that comes at you with a model, they can be quite dispassionate about it, right? They can remove any empathy or emotion from it and say the model and the data says this. And as we've just seen from this analysis, the data does say that. Well, let's ask a question about the data. Do we trust this data? Right, because we might base an entire decision on the data set. Do we trust the data?
It's coming from a reputable source. So with that grain of salt, yes, I would say that this is a trustworthy data. And of course, luckily this data set didn't have too many missing data points. Now, if we were in a situation where the data is sort of corrupted in a way, right? Whether that's missing a lot of data and there's something like, could be something fishy going on. I don't know, because they're sometimes inputting these data manually, right? There could be human error, a bunch of things. But just from doing the exploratory data analysis and visualization itself, it looks pretty solid. Yeah. So again, if you take that sort of opinion, then the fact that the auditor is proposing or engaging this thought exercise, it's reasonable, right? And the solution that you might come up with now, that's sort of everyone else's call.
All right, so what about bias? So BMI as a measure itself is contested. There are papers that talk about, is BMI the right thing to use? That's one thing. Another thing is, even if we do end up using BMI, we know that, especially in the United States, you might find some correlation there between BMI and race. So are we baking in bias here?
Right. So those are definitely factors that you need to consider, right? Again, going back to the idea of hidden variables or latent variables. So the usefulness of the metric, the BMI as a metric, is, a lot of people are questioning its validity, right? And more importantly, there are factors like socioeconomic status, where one lives, right? We even saw the regional differences, right? There are different, especially in the US, where you have state differences in healthcare, right? So you could almost argue that there is inherent bias. Yeah. So that's definitely something that you should consider when making decisions that will sort of translate to policies down the line.
All right, well, you heard it here first. Assignment 2, we are dipping our toe in model building, starting with the basics, regression and clustering. And we looked at, quite a robust data set. We've built quite a decent model with quite decent accuracy metrics. And this is why we need you, because we do have data scientists, auditors, and all kinds of people within the healthcare context who are running models like this every day, who are running models and arriving at conclusions and are setting those conclusions into motion. They're making them into policy, etc. So let's hear from you. Let's find out what you think. Go through the assignment, look at the different assignment questions, take a moment and think about it. In many ways, we have to be objective, right? So even if our gut instinct is that, oh, this is terrible, this is wrong, remember, you would still be discussing this with someone who ran a model and who says, well, look, if I look at the scores and if I look at the data, this is what the data is telling us. So Alex, you've done a fantastic job of presenting a case. We don't know that it's the right or the wrong case. And that is why we want to hear from you in this first assignment. So it is an exercise in critical thinking. We know that the data scientist is not always right. We know that the auditor is not always correct, but we need to hear from you and to empower you to have the confidence to be able to discuss this in the assignment. All right, folks, so that brings us to the end of this recording. Next steps, you've got the assignment document. Click on that. It'll give you access to the Colab file where the actual code is run. You can also watch the code video, and that's Alex talking through his assignment code. And then this piece where we just have a bit of a chat about some of the elements in the assignment. So do you have a last slide, Alex?
No, that's it.
All right. Okay.
I'm really excited to read everyone's response and sort of engage in this thought exercise.
Fantastic. All right. So Alex, we're going to let you go. Thank you so much for your time and for your effort in this really, thoughtful assignment. And folks, we'll see you in the assignments. Have a great day.